Okay, in this section of the lesson we're going to be talking about even and odd properties. Which of the trig functions are even, which are odd, and we're going to just talk more and more about which ones are even and which ones are odd and why that is. So, like we did in an earlier chapter this year, when we're determining whether or not a function is even or odd, remember what we would do was plug in negative t or negative x or whatever your unknown is into that same function and see what your outcome is. And remember, when you plug a negative into the function and then you simplify the function and the negative goes away, it's even. If the negative stays, it's odd. And if when you plug the negative in, it manipulates the function in another way, then it's neither even nor odd. So what we're going to do is look at each one of these trig functions separately. If we plug negative t into sine of t, remember, sine of t is the y value. So sine of t, let's just look at sine of positive t. Sine of positive t in this case is just going to be the y value, which we don't know what that is, but we know that that is positive. Okay, if we find sine of negative t, do you see if we rotate negative t units, we're going to rotate into quadrant 4. And when we rotate into quadrant 4, do you see that the y value that was positive in quadrant 1 is now negative? Does everybody see that? This was the quadrant 1 y value, which was positive. Now we have the quadrant 4 y value, which is negative. It's the same rotation, or the same amount of rotation, it's just in the negative direction as opposed to the positive direction. So, because of that, our positive y value actually becomes negative y. So, the sine of negative t is going to be the same thing as the negative of the sine of positive t. So, for that reason, sine is odd. Because when you plug negative in, it makes the function negative. Now let's look at cosine of t. Cosine t, remember, is the x value. So when we rotate t units and we rotate negative t units, do you see that these 2 points, whether it's a negative rotation or a positive rotation, our x value is still going to be the same positive. Whoops. Let's see if I can undo that. Our x value is going to still be positive here. It's going to be that distance. So the cosine of negative t is the same thing as the cosine of positive t. They're both the x value. So for that reason, do you see that when you plug a negative in, the negative goes away? That makes cosine an even function. Now let's look at tangent of negative t. Tangent of negative t is, remember, sine over y over x, or sine over cosine. So do you see that the y is negative sine t and the cosine is, the y is negative sine t, the x is cosine t. So if you put negative sine t over positive cosine t, you get negative sine t over cosine t. Since we plugged the negative in and it made the function negative, tangent is odd. Okay, now let's look at the reciprocals. The reciprocals are always going to be the same as their original functions. So cosecant of negative t is going to be the same thing as sine of t. So cosecant is going to be odd. Secant of negative t is going to be the same thing as secant of positive t, which is going to be even. And cotangent of t is going to be negative cosecant t over secant t, which is negative cosecant t over secant t, which is odd. Okay, so what we're going to do now is use these properties to determine the value of a negative rotation of a trig function. Sine of negative pi over 6. Now remember, sine is odd. So that means when you take the sine of a negative value, that's the same thing as the negative of the sine of positive pi over 6. So now that we figured that out, now that we know that that's the same thing as the negative sine of positive pi over 6, now we need to figure out what the sine of pi over 6 is. So the way we do that is we draw our little unit circle. Pi over 6 is 1/6 of pi. So we know that's going to be in quadrant 1 somewhere. Draw a reference triangle. Pi over 6 radians, multiply by 180 over pi. And you see that that becomes 30 degrees. So if this is 30 degrees, this is 60 degrees. Our two side lengths are going to be across from 30 is 1/2, across from 60 is √3 over 2. So our answer is going to be the negative of the sine of pi over 6. Remember, the sine is the y value. So this is going to be the negative of the y value here, which is negative 1/2. Now, let's find the cosine of negative pi over 4. First, we have to think this through. Cosine, we determined, is even. So now that we know that cosine is even, that means when you take the cosine of negative pi over 4, that's the same thing as the cosine of positive pi over 4. So let's draw our unit circle. Pi over 4 is in quadrant 1. It's 1/4 of pi. Draw a reference triangle. And by converting pi over 4 to degrees, you see that this is a 45-degree angle. So it's a 45, 45, 90 triangle. So we know that this side is √2 over 2. This side is √2 over 2. That side is 1. So to find the cosine, remember cosine is the x value. So the cosine of pi over 4 is just going to be √2 over 2. And that is your answer. Okay, so this brings us to the next section. Is it even or odd? How can you determine if a function is even or odd? Well, just like we did in the last, I don't remember what chapter it was, but a chapter or two ago, to determine if a function is even or odd, you replace x with negative x and manipulate the function and see what happens. So let's find f of negative x here. We get negative x squared times the cosine of 2 times negative x. Okay, so if we simplify this down, we get negative x squared is positive x squared. Then cosine of a negative, remember, because it's an even function, or cosine itself is even, that means the negative goes away. So this is the same thing as x squared times cosine 2x. So now that we've simplified this function, do you see that this is the same as what we started with? Since it's the same, you know this is even. Okay, so let's try another one. Let's try f of x equals e to the x sine x. So let's plug in negative x everywhere you see x. So you get e to the negative x sine negative x. Okay, so in simplifying, e to the negative x is the same thing as 1 over e to the x, right? Then sine of negative x, let's look back and see that sine is an odd function. Because we know sine is an odd function, that means that whenever you take the sine of a negative angle, that makes the entire function negative. So that's going to be the same thing as negative sine positive x. So now, if we simplify this one more time, we can move the negative to the front. We get negative 1 over e to the x sine x. Now, we have to look at this. Is there any way you can factor out the negative here in this and make it look like this? Hopefully you can see there is no way, because our e to the x that we started with was in the numerator. Now our e to the x is in the denominator. So no matter what you do, these do not look alike, and they never can, even if you factor a negative out. So for that reason, you know that this is neither even nor odd. Okay, so now let's look at f of x equals x sine cubed x. So we'll plug negative x in. Whoops, negative. So we get negative x times sine. Whenever you see an exponent over a trig function and it's before the variable like this, that's basically the same thing as saying sine x cubed. Or, well, so this would actually be f of negative x equals negative x sine negative x cubed. It's just a shorthand notation. When you see the exponent before the variable, it's just a way of not having to write the parentheses every time. That just means you're cubing the entire sine of x, not just x itself. Okay, so now what we need to do is evaluate this. Negative x remains negative x. Whoops. Okay, so we have f of negative x equals negative x. Then sine of negative x, we remember, is, since sine is odd, that's the same thing as negative sine x cubed. And now we have to simplify this again. When you cube a negative number, what happens? Since sine is negative and we're cubing it, since it's cubing and not squaring it, the negative stays. So now we have f of negative x is negative x sine x cubed. So do you see that since the negative stayed, I just moved it to the front? And now you see we have a double negative. Because we have a double negative, I'm going to make them positive. So f of negative x is going to be x sine cubed x. We'll put the exponent, or put the exponent back in front of the cube. And do you see that now that we have simplified this down completely, this has gone right back to what it started with? Because they match. This is an even function. And then lastly, let's do one more. Let's find the cosine of the sine of x. Okay, this is not, do you notice that this is not cosine x sine x? This is not cosine times sine. This is cosine of the sine of x. So we're going to find f of negative x, which is the cosine of the sine of negative x. Okay, let's look at sine of negative x. The sine of negative x, remember, since sine is odd, the negative goes in front. So we're going to say f of negative x is equal to cosine of negative sine x. Now, what we need to look at is we're taking the cosine of a negative sine x. Remember, since cosine is even, when you take the cosine of a negative, that negative just goes away. So f of negative x is equal to cosine of, now the negative goes away, sine x, because we took the cosine, which is an even function of sine of x. So now that we've taken the cosine of that and simplified it down, do you see yet again that this matches this, so we know we have an even function. Let's check our time. 13 minutes. We're going to go ahead and stop and start a new video. Okay, today we're going to be looking at section 5.2 trigonometry.